The internet is, well, it's full of rabbit holes. You know that. We all know that.
Oh, absolutely.
But today, we aren't just looking at, your standard fringe theory. We are looking at a stack of actual engineering documents, thermal calculations, and physics experiments.
Right. Things that claim the world basically isn't what we think it is.
Exactly. It is definitely not your standard government cover-up conversation.
No, it really isn't. It has a completely different tone.
Yeah. So we are doing a deep dive today into a cult classic YouTube series. It's called Balls Out Physics by a creator named Brian Mullin.
And the hook here, I think, isn't philosophy or scripture.
No.
It is straight up structural engineering.
Which is such a key differentiator for the source material. Because Brian Mullin appears in these videos not as some mystical guru. He's an educated engineer.
Yeah, and he actually claims he started this whole project to debunk flat Earth theory.
Right. He wanted to use his engineering degree to just prove the math of the globe works out perfectly.
But instead, he claims he found what he calls impossibilities.
Impossibilities in the standard model.
Exactly. He argues that the physics of a spinning ball actually contradict the reality of mechanics, thermodynamics, and propulsion.
And before we get into the math, there is a bit of digital archaeology here too, right? Because his channel, it just sort of vanished.
Completely vanished from the internet. The playlist we are analyzing for you today is actually a re-upload. It's titled The Complete Collection.
Right, minus that one Scientism Exposed documentary, which isn't part of his core physics arguments anyway.
Yeah.
So we are leaving that entirely out of this deep dive.
Makes sense. Sticking to his actual series adds this layer of mystery to it, almost like we are reading a lost manuscript.
It really does. So here's our mission for you on this deep dive. We are going to strip away the noise and look impartially at the very specific mechanical arguments Mullin makes.
We'll look at his math on airplanes, his thermal paradox regarding the atmosphere, and then finally his pivot into some really wild experimental and mystical territory.
Right, going from the calculator to the cosmos. Let's just dive in.
Let's do it.
Let's start with what seems to be his strongest suit, which is mechanics. Specifically, planes on a spinning ball.
This covers the first chunk of his playlist, yeah.
Yeah. He opens with a problem that I think, honestly, most people never even consider. The atmosphere.
Ah, the spinning atmosphere problem.
Right. So the standard premise is that the Earth is spinning at roughly 1,000 miles per hour at the equator.
And standard physics tells us the atmosphere spins with the Earth.
Right. Due to friction and gravity, the air is just dragged along. But Mullin looks at this strictly as an engineer, as a fluid dynamics problem.
He uses this analogy of a blender or even a spinning top.
Yeah.
If you spin a solid object, the air around it doesn't just instantly lock into perfect sync.
There is slippage.
Slippage, turbulence, drag.
He argues that for the entire atmosphere to spin at 1,000 miles per hour in perfect lockstep, with the ground without massive, constant, hurricane-level winds at the boundary layers, is mechanically impossible.
It's a fascinating way to visualize it, but he takes it a step further with the north-south dilemma.
Yes, this is where the engineering brain really kicks in.
And this was the part of our source notes that actually made me stop and try to visualize it in my head.
Because the Earth is a sphere, the spin speed isn't constant everywhere, right?
Right. At the equator, you are moving 1,000 miles per hour to the east, but as you travel north, the circumference of that circle gets smaller.
So the ground speed drops.
Exactly. By the time you are near the North Pole, the ground is barely rotating at all compared to the equator.
So Mullin's argument involves a plane taking off at the equator. It's sitting on the runway, so it already has that 1,000 mile per hour sideways momentum built in.
Yes, basic conservation of momentum. If that plane takes off and flies due north, it retains that 1,000 mile per hour eastward speed.
But the ground beneath it is slowing down.
Right. So Mullin argues that the plane should begin to drift massively to the east, effectively outrunning the slower ground beneath it.
It's like stepping off a fast-moving walkway onto a slower one.
You'd stumble forward.
Right, you'd be thrown off balance.
Exactly. He claims that a pilot flying north would have to constantly bank the plane to fight this drift, just to fly in a straight line over the ground.
And since pilots don't report having to constantly fight this huge Coriolis drift of hundreds of miles per hour, Mullin sees this as a fatal flaw in the rotating globe model.
He also touches on the geometry of flight there, specifically the nose-down argument.
The artificial horizon issue.
Yeah. If you are flying 500 miles per hour around a sphere, the surface is constantly curving away from you beneath the plane.
Right. So to maintain a constant altitude, say 30,000 feet, Mullin calculates that the pilot would have to constantly pitch the nose of the plane down.
Because if they flew perfectly straight and level,
They just fly right off into space.
exactly, the Earth would just curve away beneath them.
And Mullin points out that the artificial horizon, the gyroscope instrument that pilots use, stays rigid in space.
Right. If the plane were constantly nosing down to follow the curve of the Earth, that instrument would show a constant dip.
But he claims it shows perfectly level flight, implying the plane is actually flying over a flat plane, not a curving sphere.
It is an interesting argument because he isn't using complex astrophysics here. He's just using basic geometry and basic navigation.
But let's go a bit deeper, because segment 2 of our stack attacks the actual force holding it all together, gravity.
He really goes after the big G, the gravitational constant.
He focuses heavily on the Cavendish experiment. Now, for you listening who maybe haven't been in a physics lab in 20 years, can you refresh us on what that is?
Sure. Historically, this was the experiment designed to calculate the density of the Earth. It basically involves measuring the incredibly tiny gravitational attraction between lead balls suspended in a shed.
And Mullin breaks this whole setup down and essentially calls it faith-based physics
Because of the scale, yeah.
because of the massive potential for environmental interference.
Exactly. He argues that gravity in the standard model is presented as this Janus-faced force. On one hand, it's supposedly powerful enough to hold quintillions of gallons of ocean water to the surface of a spinning ball.
But on the other hand,
It's weak enough that a tiny butterfly can just flap its wings and lift off the ground.
Mullin finds a huge contradiction in those mechanical requirements.
He asks a very direct question. How can a force be strong enough to glue the entire Pacific Ocean to a spinning rock, yet weak enough to allow cigarette smoke just float upward?
And he ties this into the spinning ball problem again, specifically looking at centripetal force.
Right. If you spin a wet tennis ball, the water just flies right off. That is centrifugal force in action.
So Mullin argues that at the equator, where the spin is 1,000 miles per hour, that flinging force is absolutely huge.
Meaning gravity acting as the centripetal force here has to be strong enough to overcome that massive spin and still hold the water down.
So logically, following that math, we should weigh a lot less at the equator than we do at the poles, right? Because the spin is actively trying to throw us off into space.
And that is actually what standard physics predicts. We do weigh slightly less at the equator.
But Mullin runs the numbers himself and argues the difference is totally negligible compared to what it logically should be.
He claims the math just doesn't balance. The flinging force of 1,000 miles per hour should be far more destructive to the entire system than what we actually observe in reality.
So he chips away at the mechanics there, but then he looks up at the sky and things get a lot hotter.
Yes.
This brings us to the thermosphere paradox.
Which is arguably his most technical engineering objection in the whole series. He looks at the different layers of the atmosphere.
Right. Mainstream science identifies a layer up there called the thermosphere where temperatures can reach 2,000 degrees Celsius.
Which is about 3,600 degrees Fahrenheit.
Hot enough to melt solid steel. And Mullin asks a very practical, very engineer brain question. The International Space Station orbits right in that layer. Why isn't it a melted puddle?
He actually pulls the manufacturing specs for the ISS. It's made of aluminum Kevlar composites.
And aluminum melts at what, 660 degrees Celsius?
660, yes. While the surrounding environment is sitting at 2,000 degrees.
Now, I know the standard scientific counter-argument here. It's the vacuum flask or the thermos defense.
Right.
Space is a vacuum. There's almost no air. So even if the temperature is technically that high, there are basically no air molecules to actually touch the station and transfer the heat.
It's like putting your hand inside a hot oven versus physically touching the hot metal rack.
Exactly. Conduction and convection don't work well in a vacuum.
But Mullin completely anticipates this counter-argument. He points to the third method of heat transfer, which is radiation.
Meaning the sun.
The sun. He argues that in a vacuum, you are constantly being bombarded by direct thermal radiation from the sun.
Unfiltered.
Yes. And this is the really crucial part of his argument. You have absolutely no way to cool down.
Because usually here on Earth, things cool down by dumping their excess heat into the surrounding air.
Right. Your car engine radiates heat, but air also flows over the radiator to cool it off. In a pure vacuum, Mullin argues the ISS is essentially a pressure cooker.
It constantly absorbs solar radiation but has no physical medium to dump that heat into.
Exactly. He claims that the thermal management systems on satellites, which are often just gold foil and thin lightweight metals, could never handle that kind of thermal load without massive industrial-scale refrigeration units.
Units that clearly aren't up there. He applies this same logic to Virgin Galactic and commercial satellites, too.
Yeah.
He basically says, show me the air conditioner that works in a 2,000-degree vacuum.
It is a really compelling engineering question. How do you shed heat when there's literally nothing around you to shed it into?
Okay, so if the heat doesn't melt you, Mullin argues the rocket won't even get you there in the first place.
Right.
Segment 4 covers propulsion.
This is where he tries to dismantle modern rocketry, using Newton's third law.
For every action, there is an equal and opposite reaction.
That's the one.
The classic textbook example is letting go of a blown-up balloon. Air shoots out the back, the balloon shoots forward.
Yes. But Mullin argues that for that push to actually happen, the exhaust gases need something tangible to push against.
Like the atmosphere.
Right. Down here, the rocket pushes against the heavy air, and that physical resistance is what propels it upward.
But in a vacuum?
There is nothing.
Now, standard physics textbooks tell us you don't actually need air to push against. You just need to throw the gas in one direction, and conservation of momentum moves you in the other direction.
Like throwing a heavy bowling ball while you're standing on slippery ice.
Exactly. You go backward.
Mullin addresses that exact concept, but he rejects it based on the principle of free expansion.
Free expansion.
Yes. He argues that because a vacuum has zero pressure, the gas exiting the rocket nozzle expands infinitely and instantaneously in all directions.
It dissipates too fast.
Way too fast. It dissipates so fast that it can't create the focused directed action needed to generate the forward reaction.
So he's saying the vacuum essentially neutralizes the thrust entirely.
Exactly. He claims the gas just puffs out into the void without doing any actual work on the rocket body. To him, space travel is quite literally propulsion impossible.
It is amazing how consistent his thought process is. He takes a standard assumption like rockets fly in space and applies a very rigid interpretation of basic physical laws to break it down.
That really is his whole method. He refuses to allow for the nuance that complex physics usually requires.
He wants the simple action-reaction model to hold up perfectly in every single environment.
And when he feels it doesn't hold up, he rejects the environment itself. In this case, he rejects space.
Up to this point in the source material, Mullin has been very much the traditional engineer at the whiteboard.
Doing the math.
Right. But about halfway through the playlist, he puts down the dry erase marker and goes outside. He starts asking his viewers to do the same.
This brings us to the force the line experiment.
He wanted to use a structural engineer's auto level, which is a very high-precision optical tool, to measure the curvature of the Earth over a long stretch of water.
The underlying logic being that water always finds its level.
Right. If the Earth truly curves, the water's surface should visibly drop away from your perfectly straight line of sight over a few miles.
He really encourages a citizen science approach here. He tells his audience, don't just trust the textbook. Go to a large lake with a zoom lens and a level yourself.
If you can clearly see the target at the other end, without it dropping below the horizon, the Earth simply isn't curved.
It sounds like he's genuinely trying to empower his audience to verify reality for themselves.
But then we get to an experiment that feels like a total genre shift for the series.
Oh, the cold moonlight experiment.
Yes. This is the exact moment the playlist shifts from rigid engineering to something closer to fringe physics.
Mullin starts to challenge the fundamental idea that the moon is just a dead rock reflecting sunlight.
Which is obviously the standard model we are all taught. Sunlight hits the moon, bounces down to Earth.
But Mullin forms a new hypothesis. He suggests that the moon emits its own unique light, and that this light is cold.
And just to clarify, not just less hot than the sun, but actively, measurably cooling.
Actively cooling. He sets up an experiment in his backyard using a magnifying glass and digital thermometers.
We all know a magnifying glass focuses sunlight to create intense heat. You can burn leaves with it.
Right. Well, Mullin tries to focus moonlight.
And what did his readings show?
In his later video updates, he claims that objects placed in direct moonlight were consistently cooler than objects placed in the shade right next to them.
That completely breaks standard thermodynamics. Light is energy. Adding energy should add heat.
Unless it's a completely different kind of energy.
Wow.
This is where he suggests the moon emits a specialized cooling energy. It sets up this deep duality. The sun is hot and drying while the moon is cold and dampening.
It treats the moon as a self-luminous source with properties totally opposite to the sun.
And this leads us directly into the final segment of our deep dive today, the esoteric turn.
Because once you decide as an engineer that the moon creates cold light, You need a completely new model of the universe to explain how that is possible.
You absolutely do. And Mullin ends up finding his new model in a very unexpected place. Medieval mysticism.
Specifically, the fire and ice theory,
Right. He heavily references St. Hildegard of Bingen.
a 12th century German abbess.
Yes, she had these famous visions of the universe structured as a cosmic egg.
And Mullin starts connecting his very modern engineering skepticism to her ancient theology.
He posits that the universe fundamentally consists of two primary elements: fire, which is the stars, and the sun and ice, which makes up the firmament or the waters above.
That is just a massive philosophical leap. We went from calculating structural drift on a commercial airliner to discussing the cosmic egg.
It's a huge leap, but for Mullin, it perfectly connects. He tries to explain the phases of the moon not as shadows cast by orbits, but as a dynamic interaction between these fire and ice elements.
Waxing and waning elemental energies rather than orbital mechanics.
And
It almost seems like he just reached the absolute limit of what deconstruction could do for him. He spent hours and hours carrying down the standard globe model, and he felt a psychological need to build something new in its place.
that's a really great observation. You can't just live forever in the debunking phase.
Right, you need a foundation.
He needed a working model of reality, even if he had to go all the way back to the 12th century to find one that fit his data.
It's almost like a deep desire for symmetry. Engineering is all about balance, right? Forces canceling each other out to create stability.
Yes.
And here he ends up with this ultimate cosmic balance. Fire and ice, sun and moon, hot and cold.
It is aesthetically a very pleasing framework, even if it completely contradicts all modern astrophysics.
Which brings us to the end. The playlist finishes on a note that honestly has nothing to do with physics or math at all. It's a video simply called Givers and Receivers.
This is his philosophical outro. Mullin basically categorizes humanity into two camps. Receivers are the people who just accept information. They accept the textbooks, the nightly news, the settled science. They passively consume reality.
And the givers.
Givers are those who produce, the ones who verify, who do the actual work. He argues that the globe model intentionally turns us into receivers, making us feel like passive, insignificant specks on a meaningless rock spinning through a void.
But questioning it, testing it yourself, that makes you a giver.
Exactly. It gives you your agency back.
So the entire project, the math, the moonlight, the madness, it was all a moral imperative for him.
Precisely. It wasn't just about the physical shape of the Earth. It was about the shape of the human mind. Are you an active participant in reality, or are you passive?
That is a really powerful place to land. We started with a structural engineer just looking for basic mathematical errors in a flight manual, and we ended up questioning how we relate to truth itself.
And I think that's the real value of balls-out physics as a piece of source material. You don't have to agree with a single calculation he made.
And again, mainstream science has robust answers for all of his specific mechanical objections.
Of course, but you can still appreciate the sheer force of will it takes to look at the entire accepted world and say, I am going to check the math myself.
It brings up a very provocative thought to leave you with today. Brian Mullin spent hundreds of hours in his backyard pointing infrared thermometers at the moon simply because he completely refused to take given knowledge for granted.
He wanted to see it with his own eyes.
So when was the last time you tested a fact you just take for granted?
And not just Googled it to see what someone else says, but actually tested it in the real world.
It is a lot harder than it sounds. That's it for this deep dive into the engineering of skepticism. Thanks for listening, and keep questioning everything.